Sound, Chapter 21, Sections 1, 2, 3, and 4. All sounds have one thing in common. They are an example of a longitudinal wave. Sound and vibrations. Sound is created by vibrations. A vibration is a back and forth motion. Sound waves travel in all directions from the source that made them. Sound waves do not move matter along with the sound energy. All sound waves require a medium to travel through, so they are an example of a mechanical wave. Sounds are always made anytime particles are caused to vibrate in a longitudinal wave. People have to be around to hear the sound. Section 2. The differences between sounds depend on the sound waves. The speed of sound. The speed of sound depends only on the medium in which the sound is traveling. No matter how loud you yell, the sound waves arise at the same time as a whisper. Sound waves travel most quickly through solids and through warmer temperatures. In solids, the particles are closer together, so it takes less time for the vibration to transfer from particle to particle. In warm mediums, the particles are already energized and they're moving quickly, so therefore it takes less time for the vibrations to transfer. Pitch and frequency. Pitch is how high or how low a sound seems. Pitch is determined by frequency. The greater the frequency, the higher the pitch. The Doppler effect is the change in frequency that occurs when the sound source is moving or the listener is moving. As a sound source approaches the listener, the waves are compressed, resulting in shorter wavelengths and therefore higher frequency. This also causes the pitch to be higher. As a sound source moves away from the listener, the sound waves are stretched, better known as rarefaction, resulting in a longer wavelength and a lower frequency. This causes the pitch to be lower also. Someone writing in a sound source always hears the same pitch. Loudness and amplitude. Loudness is a measure of how well a sound can be heard and is determined by a wave's amplitude. The unit used to measure loudness is a decibel. When sound waves interact, they can be used to gather information from the world around us. Reflection of sound waves. A sound wave that bounces back after striking a barrier is known as an echo. Sound best reflects off of a smooth, hard surface. Interference of sound waves. When two or more sound waves interact, it results in what is called interference. There are two types of interference, constructive and destructive. Constructive interference is where the compressions of each wave overlap, increasing the amplitude, causing the sound to be louder. Destructive interference is when the compression of one wave overlaps the rarefaction of another wave, decreasing the amplitude, causing the sound to be softer. Planes that travel faster than the speed of sound break the sound barrier. The sound barrier is a high-density compression caused by constructive interference. When planes break the sound barrier, it results in sound waves combining to form a shock wave. The sonic boom is a shock wave that reaches your ears. The difference between a pleasant sound such as music and noise has to do with sound quality. Sound quality is the result of several pitches mixing together. Noise is a random mix of pitches and consequently frequencies.